In late September 2024, an extreme rainfall event dumped over 300 millimeters of water on the Kathmandu Valley in just 3 days. The sheer volume of water claimed 246 lives and caused over $345 million in economic losses. The scale of infrastructure loss was immense. Submerged hospitals and blocked highways cut off the capital, with 41 major roads completely destroyed. Emergency crews spent days navigating dangerous urban rapids that had turned narrow neighborhood streets into waist-deep rivers. While the rainfall was extreme, the severity of the disaster has forced a difficult question. How much of this devastation was a natural anomaly, and how much was a consequence of the city's own development? The 2024 floods exposed a pattern in Kathmandu, a tendency to treat predictable urban drainage failures as unavoidable acts of God. To understand the damage, we have to look at the valley's floodplains, which have been systematically paved over by rapid, unplanned urbanization. This chart tracks the valley's transformation since 1990. Built-up areas skyrocketed to over 60%, replacing natural sponges with concrete. The Melamchi project added a new stressor. Up to 80% of its water returns as wastewater, pre-filling drainage capacity before monsoon rains begin. By stripping away its natural drainage paths and overloading its pipes, the city had effectively engineered its own vulnerability to the rains. In Tokyo, these risks are a constant reality. 30% of the population lives below sea level, yet the city manages massive typhoons with minimal disruption. This stability is the result of a long-term financial commitment. Between 1990 and 2010, Japan dedicated 51% of its entire disaster budget to mitigation and preparedness. Tokyo uses decentralized surface engineering to absorb water where it falls. Permeable pavements and artificial infiltration trenches turn city blocks into functional sponges that recharge the groundwater. These surface systems are backed by a central monitoring network. Unlike the fragmented communication chains in Kathmandu, Tokyo's operators use real-time data to trigger automated pumps and floodgates the moment water levels rise. Tokyo survives because it approaches urban water management as an active, interconnected nervous system. But when surface systems reach their limit, Tokyo relies on a massive engineering failsafe. Known as the Metropolitan Area Outer Underground Discharge Channel, this 6.3-kilometer tunnel runs 50 meters below the surface to intercept overflowing rivers. 5 colossal 70-meter-deep vertical silos act as the intake points, swallowing massive volumes of floodwater. As millions of gallons cascade into these shafts, they instantly relieve the hydraulic pressure on the city streets above. The water eventually reaches a pressure-adjusting tank. Supported by 59 enormous pillars, this chamber controls the momentum of the floodwater before reaching the drainage pumps. 4 modified aircraft gas turbines then pump that water out at a rate of 200 cubic meters per second, discharging it into the wide Edo River. Simultaneously, automated floodgates close across the bay to prevent ocean storm surges from pushing seawater back into the river network. This system provides a geographic override switch, allowing Tokyo to neutralize its vulnerability to the sea. Kathmandu cannot afford to build a multi-billion-dollar subterranean temple. However, it can adopt the Build Back Better philosophy that Japan introduced at the 2015 UN World Conference on Disaster Risk Reduction. This begins with policy reform. Nepal must untangle its overlapping government mandates and provide local disaster committees with the resources they need to act before the water arrives. On the ground, the priority must shift toward halting river encroachment and enforcing land use policies that protect remaining floodplains. A realistic alternative is low-impact development. Simple infrastructure, like bioswales, uses vegetated channels to filter and absorb runoff. Zooming out, connecting these features across a neighborhood mimics Tokyo's permeable approach, giving monsoon rains somewhere to go. Extreme weather may be inevitable, but the resulting catastrophe is not. Kathmandu must stop treating water as an enemy to be fought and start managing it as an integrated system.